Welcome to this LangChain module, empowering ChatGPT with superpowers. Throughout this module, we'll learn how to endow ChatGPT with additional functionalities thanks to LangChain open source tool. With LangChain, we can process large feature sets like extensive PDFs. We'll also be able to link different language models and provide these models with access to external knowledge bases. Large language models, such as ChatGPT, are quite generalist in nature. This means that while they might perform data and information generation in a specific field well, they may not be able to provide us with precise answers to certain questions. They also can carry out series of tasks that require in-depth knowledge about a topic or expertise in a particular field. For instance, imagine we wish to use ChatGPT to answer questions about a specialized field. While large language models may be capable of answering general questions about this field, they may not be able to provide more detailed or specific answers requiring specialized knowledge or experiences in these fields. So, what can we do if we want to employ large language models? What if we wish to have custom or specific language models? The solution is to use LangChain. LangChain is an open source tool that can be used to work with large language models and give them additional capabilities, like the ability to learn from an external knowledge base. To overcome these limitations of large language models, LangChain offers a highly useful approach. It takes a text corpus and processes it by breaking it down into fragments or summaries. Then, these fragments are incorporated into a vector space, and similar fragments are sought when a question is posed. Here is an example of how it works. Let's imagine that we want to process a 90-page PDF. We already know that ChatGPT has a limitation in terms of the amount of information it can accept as input, so we could use LangChain to enable it to learn from all that extensive information. What would the process look like? It would take the input text and fragment it into vectors. Then, to answer a specific question about that PDF, it uses a similarity search to find the fragment that contains the answer to the specific question. In this way, the large language model could respond to us in natural language with that knowledge. This method of pre-processing information and interacting with large language models is common and can also be applied in other scenarios, such as code search or semantic search. Additionally, LangChain provides an abstraction that simplifies the entire process of composing these text parts. It is a sort of instruction pipeline system that we can use very simply according to our needs. In fact, if we go to LangChain repository, we'll see how it has experienced spectacular growth in a short period of time since its creation. We can observe how it has garnered more than 6,000 votes on GitHub in just a few weeks. Therefore, it is a library that is rapidly gaining popularity and proving very useful for users. In this task, we will discuss different requirements of LangChain, as well as the different models it gives us access to. As for requirements, all we need is an API key from our large language model. In recent months, we have been working with the LangChain model. We are experiencing a boom in the emergence of countless large language models where different developers or companies have each developed their large language model. Initially, the most well-known model was ChatGPT, but now different companies have also developed their own models such as Llama, Bloom, or GPT. As users, we have the option to choose between proprietary large language models, that is, paid models, for which we need the API key, or open source models, depending on the balance we strike between the performance we want to achieve and the cost. On the one hand, we have proprietary language models, which are closed source, owned by various companies and developed by experts. They are generally larger than open source models and therefore also perform better. But we also have to bear in mind that they have costly APIs. Some examples of the best known proprietary models would be those from OpenAI, but there are also those from Cohere, AI21, OLabs or Anthropic. On the other hand, open source models are usually smaller models with fewer capabilities than proprietary models, but they are most cost effective than proprietary models and most are entirely free. Some examples of open source models would be Bloom, developed by VG Science, Llama, developed by Meta, Flantify, developed by Google, and GPT-J, developed by Eleuther AI. As we can see, we have the option to choose between different types of large language models based on whether we need more performance, in which case it is better to go for proprietary models, or if we need to have a lower cost, then we can turn to open source models. Also worth noting is the Hugging Face page, which is a portal where different open source models are published, giving us access to various models. As we already know, there is a wide variety of large language models available, and LangChain provides us with integrations for a large number of them. In addition, it provides us with a simplified interface for connecting with the different models. In LangChain, we differentiate three types of models that are distinguished by their types of inputs and outputs. On the one hand, we have conventional large language models, such as ChatGPT, which take a string of text as input, which would be the prompt with the user's instructions, and generate a string of text as output. In this case, for example, the prompt would be that Alice has a parrot, and the question is what type of animal is Alice's pet. We send it to ChatGPT, for example, and ChatGPT would return the answer. This would be the large language model. Then we have the chat models, which are similar to the previous ones, but instead of a single string of text, they take a list of chat messages as input and return a chat message as output. That is, the input of these chats would be a conversation instead of a single text input. Finally, we have the embedding models. These models receive text as input and return a list of numerical values known as embeddings, which are the numerical representation of the input text. These embeddings help extract information from the text that can then be used, for example, to calculate similarities between texts or summaries. This would be the other example, in which the input also takes a text, but these embedding models, instead of returning an output in text format, return a numerical representation of the input text. And as we have already mentioned, it can be used to identify the similarity between different input texts. To give us a more approximate idea of how these different types of models work, let's go to the LangChain documentation to the model section, which is where we will find the information. In the documentation, we have, for example, a Getting Started section, where it gives us an example. We had mentioned that there were like two types of models, the conventional ones and the embedding ones, and within the conventional ones we had the standard LLMs and the chat models. And how do they work with LangChain? Well, we would have to import the libraries, as is always done in Python, with any library we are going to use. We use the OpenAI class, this for the conventional model, or chat OpenAI for the chat models, which would be this other one here. And it would be as simple as calling the model that we just imported here, and with the predict function we pass the prompt. In this case, the instruction is to say hello, and then the chat will return hello. And for the chat model it would be the same. We use the chat model-predict function and pass the input text. As we can see, very simple. We also have the option to add messages, as in this case with the human message function, which would be a function very similar to the previous one. And here we would have the response from the chatbot. Within models, we had mentioned that we had these three types of models: the conventional LLMs, the chat, and the embeddings. We could go to each of these sections to the option, for example, Getting Started, to see how each one of them works. Let's look at, for example, the chat ones, which are very similar to the previous ones. We would have to import the function, which would be the chat OpenAI function, and directly pass the input text. In this case, we are passing different concatenated messages, which would be to translate a phrase, and then the phrase is passed, which would be I love programming. We can do it this way or change different messages for the chat, which would be done this way. It would be the system message, which would be a sort of system message, where we are going to indicate that the chatbot has to do. All of this is explained here, and then the human message, which would be the content that we want in this case to translate. And, as we had mentioned, it allows us to change different messages and then get the result. If we have any questions about the different types of models, all we have to do is go to the models section in the LangChain documentation. In this task, we'll learn about the prompt functionalities in LangChain. To achieve good results with large language models, we know that using appropriate prompts is crucial. The process of generating these prompts is known as prompt engineering. As we have seen in previous tasks, this prompt engineering part and providing concise, relevant, and contextual instructions to the language model is essential. It makes a difference between getting average results with models like ChatGPT or achieving good results. Once we have designed a well-crafted prompt, it is common to want to use it as a template and reuse it multiple times. That's why LangChain offers prompt templates that help us construct prompts using multiple components. How do we use these prompt templates? As shown on the screen, the first step is to import the prompt template function from LangChain. Then, we construct the template variable, which has a fixed, invariant part and a variable part represented by arguments. In this case, the argument is product. This product argument will be modified based on the call we make. We generate the prompt using the prompt template function, passing the input variables, in this case product, and the complete template. When we want to use the large language model with this template, we simply use the prompt.format function and indicate the input variable, in this case product. We specify that it will be colorful socks. What are we doing with this? We are providing ChatGPT, for example, with the command "what is a good name for a company that makes?" and instead of product, it will take the value we specify in the call, in this case, colorful socks. If we want to pass the product name as multicolor sneakers, we would put multicolor sneakers here. By doing this, we generate a standard template to obtain names for companies related to different products. If we want a colorful socks name, we put colorful socks. If we want sneakers, we would put a sneakers here. This way, we can reuse the same prompt for different use cases. Additionally, if we observe this prompt, we haven't provided any context or examples to the large language model. As we have seen before, a prompt engineering technique is to send a series of examples, known as fused prompting, so that ChatGPT learns from those examples and identifies what is intended correctly. How do we include this prompt engineering technique through LangChain templates? Import the prompt template function and also the fused prompt template function. Next, we define the examples on which the model, such as ChatGPT, will learn. We indicate that for the input happy, the output should be sad, and for the input tall, the output should be short. In this way, we provide two examples. As we can already infer from the examples, what we are aiming for is to obtain the antonym of the input word. Next, we define the template, word that will take this variable and antonym that will take the next variable. In the template, we pass happy, which should result in sad. Then, we use the prompt template function to construct the template, passing the input variables that will take the meanings we want. That is, we will pass the desired input word and it will use the example template. Then we use the fused prompt template function, which utilizes the examples, the example prompt we defined here, and the prefix we pass. The instruction we give to ChatGPT would be, as a prompt, give me the antonym for each input. The suffix, which in this case would be the examples, would be word with input, and we had previously defined input as the first word, followed by the antonym. By doing this, the model learns, and finally we pass the variable for which we want to obtain the antonym, which we do here. In this case, we'll use a template that has a fused prompting programmed to obtain the antonym of big. This way, we can generate templates that are much more effective than if we don't use examples, as shown on the left. It is a bit more complex to generate, but it is much more effective in obtaining good results. In this task, we'll learn about the chaining component in LangChain, which allows us to combine our large language model with other components. Chaining in LangChain refers to the process of combining large language models with other components to create a unified application. Some examples include combining large language models with request templates, sequencing multiple large language models, combining large language models with external data, and combining large language models with long-term memory. To achieve this, we can use the LLM chain function in LangChain, which is the function we see here. In this case, it is a simple chaining where we are only specifying the input variables to relate a prompt to those input variables. If we want to create a more complex chaining process, we can use the simple sequential chain function. In this case, we would be chaining multiple components. On one hand, the prompt we generated here, and on the other hand, an additional command where we want to get a short phrase for the company. We would be getting the result of the prompt we are using here, and also chaining the result of this second command. This second component is a bit more complex. We generate it using the prompt template function, and we need to pass dynamic input variables that will be modified based on our needs. Then we have the template with a fixed part and the variable part with the input variable. After that, we use the LLM chain function to establish the relationship between these two prompts, and finally we combine the first and second prompts using the simple sequential chain function. We pass chain 1, the chain 2 we just generated, and that's it. We can directly execute both commands related to a single call with the run command. We pass colorful sorts, which is the company name, and it will return the result of the chaining of both commands. Finally, if we execute this code, we will get the result of the first prompt, which is to get the company name, Happy Socks & Co., and then the second prompt will automatically be launched, giving us a short phrase for that same company along with the new company name. So the result will be a step into colorful comfort, followed by the proposed company name. The first part comes from the result of the first command, and the second part comes from the result of the second command chained with the first. This method will be useful, especially when we need to combine outputs. For example, if we want to ask ChatGPT for multiple things, and we want to perform one action based on the results of another, this would be the ideal scenario where we can use chaining. In this task, we will learn how to use LangChain indices to give ChatGPT access to external data. Large language models have the limitation of not having access to contextual information, such as specific documents or specific information. However, this limitation can be overcome by using LangChain. LangChain allows us to load external data using a document loader. It offers different loaders for different types of documents, such as PDF documents, emails, websites, or even YouTube videos. Once the data is loaded as documents, they can be indexed using a text embedding model in a vector database, such as Pinecone or Weaviate. In the next example, we will use Face, a vector database that does not require an API key. We will start by importing information from YouTube videos directly. To do this, we need to import the LangChain functions from document loaders, which will allow us to load information from YouTube videos using the YouTube loader function. We simply need to provide the URL of the video and use the .load function to load information. Once we have loaded information from the YouTube video, we convert it into a document and store it in the Face vector database. At this point, the document, which in this case is the video, is stored as an embedding in Face. Now we can use this information to ask specific questions about the YouTube video. To do this, we use the chain function, specifically the retrieval QA function, which allows us to ask questions. We define the query we want to ask related to the video we just loaded and launch this question to the model in QA format. The model will search through all the information it has acquired from the YouTube video and return a result to us. This is extremely useful when we want to enrich our natural language model with updated information or specific documents. We can obtain large language models specialized in a specific topic. For example, if we pass a medical document that talks about the brain, our model could acquire that specific knowledge, and we could ask it natural language questions for it to respond using the information it has learned from that brain article. This can be extrapolated to different use cases, as we have seen in this case with the YouTube video, or even trained with the enterprise databases. In this task, we will learn how to provide memory to our large language models using the memory function, which allows them to remember previous conversations. This functionality is essential in applications such as chatbots. However, large language models do not have built-in long-term memory unless they are provided with a chat history. To address this issue, LangChain offers various options for handling chat history, such as keeping all conversations, retaining only the latest conversations with the user, or even summarizing the conversation. In the example we will show, we can see a case of a chatbot developed with ChatGPT, both with and without memory. When ChatGPT does not have memory, it cannot answer questions that depend on previously provided information. But when it is given memory, it can remember and utilize information from previous conversations to respond to subsequent questions. To provide ChatGPT with this memory capability, we will use LangChain. The conversation chain function in LangChain allows us to give ChatGPT conversational memory. This transforms the model's behavior, enabling it to remember and refer to information from previous conversations. To implement this in code, we use the conversation chain function, specifying the model we want to use. With the conversation.predict function, we pass the user input, which is stored in the model's memory. This way, when the user asks a question that depends on previously provided information, ChatGPT can respond correctly. This functionality is especially useful in developing chatbots using large language models like ChatGPT. It provides them with the ability to have more coherent and contextual dialogue with the user, thereby enhancing the user experience. In this task, we will learn how to enable large language models like ChatGPT to access other tools using the LangChain Agents module. While large language models are powerful, they have certain limitations such as lack of access to contextual and specific information, inability to perform precise calculations, and the risk of quickly becoming outdated. To overcome these limitations, they can be connected to other tools through LangChain agents. These agents can provide them with additional capabilities such as internet search, for example, Google Search, calculations, Python, Perl, or Wolfram Alpha, and access to specific knowledge sources such as Wikipedia. Let's look at an example where we ask ChatGPT about Barack Obama's date of birth. Since this is a specific piece of information that can change and that ChatGPT may not know, we need to connect it to Wikipedia and a calculation tool to determine his current age. To achieve this, we first import the necessary functions from LangChain. We use the load tools function to load the Wikipedia and calculation agents. We initialize the agent with initialize agent, passing in the tools and the language model we want to use. Once the agent is defined, we simply use the agent.run function to execute tools, allowing ChatGPT to access Wikipedia and perform mathematical calculations. When we ask for Barack Obama's date of birth and his age in 2022, ChatGPT can search for the date on Wikipedia and then use the calculation tool to determine his age. As a result, ChatGPT provides us with the requested information. Barack Obama was born in 1961 and was 61 years old in 2022. This agent functionality is extremely useful in providing additional capabilities to large language models like ChatGPT, enabling them to autonomously perform searches. Some models, such as AutoGPT, are developed using this agent functionality.